we are looking at computing a Fourier transform, and this is going to be an example that is going to make us understand how to do a Fourier transform. So if I write the Fourier transform, f of t is equal to exponential of negative 2 times the modulus of t. So this kind of signal is important in signal processing. So let's look at the solution for the Fourier transform. So we are going to be converting from t domain to omega domain. This is frequency, because omega itself is directly related to frequency. So now the Fourier transform f omega is equal to integrating from negative infinity to infinity f of t exponential of negative j omega t with respect to t. So let's put our function. So f omega for this function here is going to be integrating from infinity to infinity, negative infinity to positive infinity of exponential negative 2, then t. Remember, this is modulus. And then we are multiplying it by exponential negative j omega t with respect to t. So this one, since we have some, this point, modulus of t behaves differently as you approach t is equal to 0. So for that matter, we are going to integrate this f omega, or the Fourier transform, from negative infinity to 0. Then we have to integrate this negative. Remember, if it is, see, when you have t greater than or equal to 0, if t is greater than or equal to 0, then t is positive. But if t is less than or equal to 0, then you have a negative t. So that means here, between 0 and negative infinity, we have a negative 2, then times negative t, exponential of negative j omega t with respect to t. Then we are adding, integrating from now 0 to infinity of exponential of what? This is going to be negative 2, but now times t, because between 0 and positive infinity, we have a positive t. Then exponential negative j omega t with respect to t. So this is going to be the Fourier transform. So we are going to have negative infinity to 0. Then we have exponential of, this is going to be positive, so it is going to be 2t minus j omega t with respect to t, plus integrating from 0 to infinity of what? This is going to be exponential of negative 2t minus j omega t with respect to t. So if I consider this as integral 1 and this as integral 2, then so integral 1 will equal to, from negative infinity to 0 of exponential, we will have 2 minus j omega t with respect to t. And then, integrating an exponential function like this, we get exponential of 2 minus j omega t divided by 2 minus j omega. So we are going to put in limits from negative infinity to 0. So this I1 will become, if we put in, this becomes exponential power 0 minus exponential of negative infinity, because this is going to be very big. When you multiply it by infinity, it becomes so big. So divided by 2 minus j omega, and this becomes 1 and this becomes 0. So 1 minus 0 out of 2 minus j omega. So this becomes 1 out of 2 minus j omega. So that is I1. Let's look at I2. Now, I2 is equal to integrating from 0 to infinity of exponential of negative. This is 2. This is 2 plus j omega, then t with respect to t. And this is going to be exponential negative 2 plus j omega t divided by negative into 2 plus j omega. So from 0 to infinity. So I2 becomes exponential. This becomes negative infinity minus exponential of 0 divided by negative 2 plus j omega. This becomes 0 minus 1 divided by minus 2 plus j omega. So this and that will go away, and then we will have 1 out of 2 plus j omega. So meaning that solution f omega will become I1 plus I2, and this is the same as 1 divided by 2 minus j omega, then plus 1 out of 2 plus j omega. This becomes 2 minus j omega into 2 plus j omega. Then this becomes 2 j omega plus 2 minus j omega. So f omega, this goes, and then we'll have 4 divided by, that should be 4, which is 2 squared, then plus, then actually this is supposed to be minus, this is actually minus j squared omega squared, which becomes 4 divided by 4 plus omega squared. So the Fourier transform of f of t equivalent to exponential of negative 2 modulus t is equal to 4 out of 4 plus omega squared. So we have transformed this function from time domain to frequency domain. So my dear friends, we are given a Fourier transform problem. So if I write the Fourier transform of f of t is equal to exponential negative at squared for a greater than 0. So we need to test for convergence, because if this function does not converge, it gives useless outputs. And convergence, therefore, ensures that the Fourier transform exists and gives a finite result. So convergence ensures that the Fourier transform exists and gives a finite result. So for that matter, let's test. So have f of t equivalent to exponential negative at squared. This is the same as 1 out of exponential at squared. So now, what happens when t increases? When t increases, e or exponential of at squared also increases. When that happens, then f of t decreases. So that means if t, with t going to infinity, then what happens? A t squared also goes to infinity, and therefore f of t goes to 0. So that means this function will converge as t goes to 0. As t goes to infinity. So this is what is going to happen. So since it converges, then the Fourier transform exists. So let's look for the Fourier transform. So the Fourier transform f omega will be integrating from negative infinity to infinity of f of t exponential negative j omega t with respect to t. So what is f of t? We just substitute in, and this becomes f omega is equal to integrating from negative infinity to infinity of exponential negative at squared, then times exponential negative j omega t, and then with respect to t. What happens to this? F omega will now equal to negative infinity to infinity, integrating exponential of now this we apply rules of algebra or indices, so this becomes negative into a t squared plus j omega t with respect to t. Now a little more manipulation here gives us the Fourier transform f omega equivalent to, so we are going to look at negative into a t squared plus j omega t. So what is this going to be? Let's do, let's just manipulate a t squared plus j omega t, and we do completing squares. So completing squares here, we are going to complete a square and say this is a into t plus, remember this a is now outside, so we need to find a way of killing it inside. So j omega out of 2, but now multiplied by a. So we square this. Then when we square this, we take away j omega out of 2a, everything squared. So this becomes a into t plus j omega out of 2a, everything squared. Then minus, this actually becomes plus omega squared out of 4a squared. So that is f omega. And therefore f omega, no, this is not f omega. So our f omega becomes integrating from negative infinity to infinity of exponential of negative a into t plus j omega out of 2a, everything squared, then minus omega squared out of 4a squared. Remember, this is with respect to t. So this becomes exponential of negative omega squared out of 4a squared, integrating from negative infinity to positive infinity of negative a into t plus j omega out of 2a squared with respect to t. So we can recognize some special integral here. So relate this to Gaussian integral, whereby integrating from negative infinity to infinity exponential of negative a into t plus a constant, then squared with respect to t. This gives us what? This gives us square root of pi out of a. So what does that mean? I can replace this. This is a constant. This is t. This is negative a outside. So I can replace the whole of this with square root of pi out of a. Therefore, the integral, which gives us now the Fourier transform, f omega will equal to exponential negative omega squared out of 4a squared times square root of pi out of a. Therefore, the Fourier transform ft for f of t equivalent to exponential of negative at squared, okay, will be f omega equivalent to exponential of negative omega squared out of 4a squared times square root of pi out of a. So that's how we have been able to solve this problem.